So you mentioned three different databases, three
Right.
streams of data. How are you aggregating them?
Well, we're just beginning that process now. Right now, each system is being run, each data set, each operator's data set is being run through essentially the same type of system because we have a common platform that runs, that essentially these data sets are being run through. But over the next 6 months, we will be bringing them together at the second by second level. And the exciting thing is, because we have these different data sets, we can use one piece of information from one data set to inform the other. For example, our telco data set allows us, they're quite frankly using an internet television protocol. It's really a new plant, so every set in the home is measured. So we're actually able to create a horizontal program index to see how many television sets in the home are viewing a particular program. We can take that and then apply that to a satellite provider who may not necessarily have every set in the home wired to their set-top box device. So we can use a horizontal index from our telco information to help us with the satellite. And there's interesting things that we can do with the satellite information, because that is such a huge footprint in terms of many millions more homes that we have. We can use that to help us create some vertical indices that we can apply to the telco side. So quite frankly, we're in the process now of getting in the weeds and bringing bringing the three services together. So stay tuned because in 6 months' time we will be releasing it as a unified service.
Latency is an issue because different boxes have different latency, different data sets have different latency. How are you handling latency now, and how are you going to be handling it to aggregate?
Well, what we were able to see is, even with the different set-top boxes and the different systems, what we're able to see is, I mean, latency really is an issue when it relates to reporting some form of commercial rating. That's really where this is important. If you're talking about the average program, whether it's 3.5 seconds or 20 seconds, that's not really the issue. It's really how granular are you going to be in terms of producing a commercial rating. What we have seen across the platforms where we have introduced a special calculation, which we call the advertising retention index, we have seen a consistent pattern. At the start of a commercial pod, there is 10 to 15% of the audience that just disappears. And you see that no matter what the latency of the different devices are. So we're able to actually see that switch away and actually then see that audience come back from a mathematical calculation and create the advertising retention index that allows us to create a commercial pod rating. So we're doing that now. We have an ad retention index for a program that says, here's how your commercial pods are holding compared to the entirety of the program. And so that's a mathematical pattern that we see regardless of the latency. And I think that this will never be an exact science in the sense that you're going to get things right to the 10th of a second. But if you're talking about something that is within 3 to 5 seconds, that shows a consistent pattern of commercial switch away, commercial back, coming back, I think that you can do fairly well with what you have in terms of commercial holding power, ad retention index. I'll even use the word C3. I think all of those things can be done even in a world where you recognize that there is some sloppiness in the machines. Because there is this consistent pattern of people turning away, but it's not the majority of people turning away on live. Certainly there is that consistent pattern where people are tuning out on DVR, and you capture that as well. So the reality is, what we see in the second by second tuning information is a pattern of tuning away and coming back, and I think that overwhelms any issue of latency.
How are you treating set on, set off?
Well, what we're able to do, and again, this is the nice thing about having the different data sets, in our telco system, that's really designed, because that is a advanced plant, that is really designed that your remote device actually controls your television set as well as your set-top boxes. Now, people can override that, etc. But through that, we're able to identify what we call good set-top boxes. That is, set-top boxes where there is not a long period of time of the set-top box being on without any tuning. So from that, essentially, what we can calculate, taking those good set-top boxes, we can calculate the probability of the time between tunes that your set is on or off, because we've got boxes that are behaving as tuners. So we can create probabilities of between, let's say, the tuning occasions of 1 minute. The probability is 99.9% that the television set's still on. An hour, it might be more like 75%. Not giving you the exact numbers, but essentially we can create a curve that says between the duration of the tuning events, here is the probability that the set is on or off. And then we take that probability, and in a Monte Carlo technique, we apply that to the viewing data that we get. So what we're doing is accounting based on behavior within the set-top box world of whether that set is on or off on a probabilistic basis.